pressure.
But, like, the only thing I'm confused about is that this, how do you know that this pressure is the total pressure and not of the O2?
Because, well, since it tells you, and you just subtract it to find the O2.
Okay.
This is just how I remember it. But
Thank you.
yeah, of course. So now it makes sense now.
Yeah.
Like there's a different way to solve it. Oh, well, we got this. I guess I'm gonna have to wear this now. Huh?
Is it working at all?
Yeah, she turned it. She changed the battery.
Oh, so it's good.
Yeah.
Perfect.
Mm-hmm.
I remember it, but I don't remember how to do it. Like, that's me.
Do you have printouts or do we go on this online?
Online. Yeah.
Okay, where? On the...
So it's on the SARC website. It's not on the Study Union because I didn't know how to put it there.
Okay, so there?
No.
No.
So it's let me, I can look it up for you. Sorry. It's no, okay. So it's SARC UCF. Okay, so it's UCF SARC .wordpress.com, and then with the menu you go to Chem 2041, and it's that one.
Okay.
Yeah.
Thank you.
No problem.
There's a lot of
Okay, can you guys hear me? Yes? Okay. So I'm gonna go ahead and start. So the review is online on the SARC website. If you don't have it, the website is sarcucf.wordpress.com, and then it's on under Chem 2041. So, you guys ready? Perfect. All right. So I'm going to go over the answers. I'm going to ask you guys to tell me what the answer you got was. And if you didn't get it, we'll go over how to do it and we'll move on from there. So if you have any questions, just stop me, tell me, we need to go over that one, how do you do it, so forth. So the ACS is pretty much all the same idea. They tend to repeat the same concept over and over. They just change the wording of the question, they change the concept maybe, but it's all the same big ideas just repeated. So same chapters, same type of questions, they just changed the numbers or something similar to that. Okay, so it's number 2, but it's actually number 1. So what did you guys got for that one? C, okay. Does anyone have any questions why it's C? So that one is a limiting reactance one, okay? So all you have to do is count the numbers. So you're gonna have to count, and they tell you what is what. So first thing you're gonna count, and then from there you're gonna figure out which one's the limiting. So the limiting doesn't necessarily mean it's the least. It means it's the one that's not gonna form the most in terms of NH3s. So the most you can form is 8 NH3s, and because of that, H2 becomes the limiting factor. Good? No? Okay. Okay. From NH3. Okay, so let's look at it. So you have H2 is the open ones, so the white ones are H2, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12. You have 12 H2s. Okay? Good? That's the white circles. The black circles are the N2s, and you have 5 of these. Right? 1, 2, 3, 4, 5. Right? And you're forming NH3. So with NH3, okay, you need 1 N for each 3 H's. Right? Okay. So we're going to use that proportionality to see, okay, how many can we form? So if we have 12 H2s, that means that we have 24 H's. And if we have 5 N2s, that means that we have 10 N's, right? So even though I have 24 H's and 10 N's, H becomes my limiting factor because the most I can form, so you know that you need 3 H's, right? So if I want to use up all 10 N's, I'm going to need 30 H's because it's 1 to 3. Do I have 30 H's? No, I don't. So I'm going to use up as much H's as possible. So you divide that by 3, you realize that you can only have 8 NH3s. So if I have 8 NH3s, I'm only going to use 8 N's. So N's are going to be left over, but H's are are going to be my limiting factor because these are the ones that restricted me to only have 8 NH3s. Okay? Make sense? Okay. So the one after is going to be, what did you guys get for that one? So that one's going to be B. So do you guys have any questions on that one, or? Let me try to zoom it in more. Okay. So with that one, let's see what we're trying to do. So they give you C8H8O3. What is it called when you have CH and O? What's that called? almost. Okay, so you have C8H8O3. Okay. So what you're trying to find is the number of oxygen atoms given a 45 milligram sample of this C8 of vanillin. Okay? So you know the composition, it's 8 to 8 to 3, right? So you know that in 1 mole of C8H8O3, okay, you have 1 mole, you have 3 moles oxygen, right? You get that from the equation. So you're going to go, well, first of all, milligram is going to be converted to grams, so it's going to be 0.045 grams. So you're going to go like this. So 0.045 grams, and you're going to convert that to moles of C8H8O3, so grams of moles of vanillin. So in 1 mole of vanillin, you're going to figure this out by calculating the molar mass, and they already give that to you, which is 152 grams. Oh, I'm sorry. Okay. So they tell you in the question how many the molar mass. So it's 152 grams per 1 mole of vanillin, and then that gives you the number of moles of vanillin. And then you know that in 1 mole of vanillin, you have 3 moles of oxygen, right? Okay, and then the question is asking for number of atoms. So automatically, anytime it says atoms, what is something that we use? Avogadro's, right? So we know that in 1 mole of oxygen, you have 6.022 times 10 to the 23rd moles. Or atoms. Okay, sorry. So you are going to cross multiply across, and then the answer becomes 5.35 times 10 to the 20 atoms. So to make sure that you got a right answer, you're going to have to get some big number because it's atoms, and atoms are going to be huge. So to make sure that you got a right answer, you have to get something with a large exponent. So in the 20s, most probably, with that one. Good? Okay. So next one. What is the molarity of sodium ions in a solution prepared by diluting 250 milliliters of this? So dilution, titration, these are big things that they like to focus on. So let's see. What is the equation that we use in terms of dilation? Or dilution, sorry. So that one is going to be the, so the M1 V1 equals M2 V2. Okay, you already have one volume, so that's V1, that's M1. And then you have V2, so you're looking for M2. Okay, so you cross multiply, and the answer becomes C. Okay. Okay. Number 5, they like to ask a lot about weak electrolytes, strong electrolytes, what's going to be soluble, what's going to be insoluble. So you do not get a solubility chart on the ACS. So let me show you what the ACS reference sheet looks like. So this is the ACS reference sheet. Okay. So the first thing is abbreviations and symbols. I don't know if you can see that. Then they give you 3 equations only, and these 3 equations you don't even know because they're CHM2 equations, and then periodic table. So they do not give you solubility charts. So you're going to need to know these. So memorize these, memorize the weak acids and the strong acids because they also ask about these. And what's up? Mm-hmm. Okay, yeah. So, sorry. You know how you have 2 moles of Na? Okay. So, you will get the A as the answer, but you have to multiply it by 2. Because even though you have, so you're looking for the sodium ions, and you have 2 moles of sodium in Na2SO4. So because you have 2 moles of Na plus, you're going to multiply the 0.11 moles, the 0.11 molarity by 2. Okay, yeah, I got the answer at first too, and then I had to multiply by 2. Okay, so with 5, it's a memorization one, and that one the answer is A. So let me show you what the weak electrolytes are going to be weak acids and weak bases. So some of them are these are weak acids and weak bases. So these are similar to HF, H2CO3, H3PO4, and the weak bases are like NH3. So mostly things that contain N. So like, sorry. So there's a chart, I think in the book, that has the weak acids and the weak bases. The strong electrolytes are all the ones in the periodic table that are no, never mind. Okay, so strong acids, strong electrolytes, are strong acids. So these are like HCl, HBr, HI, HNO3, okay, and strong bases. And these are like NaOH, KOH, LiOH, okay. So you need to memorize these. These are more of memorization than anything else. So, good? All right. Number 6, the kinetic theory of gases. So that's the chapter that you guys just took, chapter 5. So the kinetic theory of gases assumes all the following except. So they like these except questions. So what's going to be the answer for that one? D, exactly. So what happens when the particles collide? It's negligible, right? And we also have conservation of energy. So energy is never lost. Okay? Just as a hint, energy is never lost. It's always conserved. Let's do number 7. Okay, that one has to deal with pressure and temperature and volume. So again, chapter 5. With these ones, they like to give you conceptual. So what will happen if you double this and triple this? Things like that. With that one, you also want to remember, okay, what do I have? So what equation should I use? So you have temperature. Okay, you have pressure, and you have volume. So it says that the absolute temperature and the volume of the container are both halved. So what's going to be the pressure? Okay, so you're going to use P1, V1 over T1, and then P2, V2 over T2. So if you are halving or making this into half, you're making the temperature half and you're making the volume half. So if I have half on top and half on bottom, they're going to cancel out, right? So that makes the pressure the same. So anytime you're doing the same thing to things that one's on top, one's on the bottom, it stays the same. If you're having, or if you're only doing half the temperature, then the pressure, what's going to happen to the pressure? It's going to double, right? But since you're doing half to both things, one on top, one on bottom, they cancel out. So you get that pressure becomes the same. Okay? All right. Number 8. That one looks familiar, right? So we're looking for delta H, and that box is an arrow. So that one is Hess's law, right? So this is going to be Hess's law. So if you have an equation, you're going to use that equation to guide you. So if I have 2 H2S, then I also need to have 2 H2S on this side. So H2S is going to be on that side. Therefore, I do multiply this by a negative 2. Negative changes it to the opposite side. And it's a 2 because I have 2 moles of H2S in the actual equation. Okay? And then I have 3 O2, and I have O2s here. So now I have to see, okay, H2O is on this one. So let's use the first one. So 3 O2, O2's on this side, it's still on this side, it's on the reactant side, so I'm only going to multiply by 3. Okay? And then H2O, it's going to be on the product side. Here it's on also the product side, but I need to multiply it by 2. Okay? The 2SO2, it's going to be on this side. So I'm going to use that same equation again, but multiply it by 2. Okay. Actually, you don't have to do that because they're going to cancel out on their own. So you're going to get 3S plus 3O2 gives you 3SO2, and then you multiply 3 by negative 296.8. And then here you're going to do 2 times H2 plus 2 times half is 1, so 102. And you get H2O, and 2 times negative 285.8. And then here you're going to flip it since it's a negative. So it becomes 2H2S, and you get 2H2 plus 2S. And since this is a negative times a negative, it becomes positive. So it's 2 times positive 20.6. Okay? You're going to cross things out. So 2S crosses with the 3S, and I get 1S as left over. All right? 2H2O and 2H2O are going to cancel. What else? So I'm going to be left with last one? That one's multiplied by -2. Oh yeah, sorry. There you go.
Thank you.
Yeah. So no, because they're both on the same side. Yeah, so you multiply the top one by 2 instead of 3, because then they cancel out, and then you would add the O2 to each other. So yeah. So it's better to multiply by 2 first. That's right. Thank you. So then you get 2H2S, and then you add these, so 3O2. What you're trying to get is the same equation again, but then what you're ultimately changing is these. These are.
Why does the last equation like that one right there or formula look like that? Isn't that supposed to be like similar to the third one?
Which one?
To the third one.
What's wrong with that?
It looks different than the other one.
Okay, so this is the overall. And these are the there's three equations that allow you to get to that. So you're altering these equations by multiplying by different factors that are similar to these. So either 2 or 3, and then you do the negative to flip it, because the H2S is supposed to be on the reactant side. So you flip it by multiplying by a negative. Okay? So what you're ultimately trying to get is the same equation as that one. So you still have 2H2S. That goes down. The 3O2, 2SO2, and 2H2O. So we're good. Okay, and then you multiply these, and then add them to each other, and you get the final answer, which is D. So you're going to multiply that one by 2. Yes. Yeah, you would change it. Sorry. Yeah, you would change it. Okay. All right, so number 9. So it says, calculate the energy released by the reaction. And again, you have the formula. They give you 1 mole of oxygen. So they give you the overall equation. They tell you how much of iron is going to react. And then they give you the enthalpy formation. Okay. So, for that one, if you have Fe2O3 and you're getting 4 Fe's, since you have 2 moles of Fe here and only 1 mole of Fe here, you're going to divide the negative 286 kilojoules per mole by 2. You see where I got that from? So because you have 2 moles of iron in the overall thing, you have to divide that by 2 because you only have 1 mole of iron that reacts with 2 moles of oxygen. Okay? So it's just Fe, it's not Fe2. Okay? So when you do that, you get 413 kilojoules. And that's the amount of iron. Okay? That's going to be the enthalpy formation for the iron. Okay? So the answer becomes B. So all that one is, you're not going to really do any equations or anything. All you need to understand is that you have 1 mole of iron reacting instead of 2 moles. Okay? All right. So the next one is, what will be the result when 15 milliliters of this molarity of lead 2 nitrate is mixed with 15 milliliters of this molarity of sodium chloride? So again, that one, you need to know what's going to dissociate, what's soluble and what's not soluble. So again, it's a solubility. So for that one, because lead 2 nitrate, so according to solubility rules, lead 2 nitrate and sodium chloride are both soluble. So you have something called complete dissociation. And when you have complete dissociation, you get clear liquid. You get no precipitate. Okay, so that one again is solubility. So lead 2 nitrate and sodium chloride dissociate completely and no precipitate is formed. So that's why you need to understand these solubility rules and memorize them. Okay, 11, oxidation number. They also like oxidation numbers. If you look through them, so this practice test is 3 past practice exams, 2014, 2015, and 2016. So one of them is very recent. They have the same exact questions. They have oxidation numbers. They all have oxidation numbers. So that's something that you should probably focus on. So with oxidation numbers, you always start with what you know. Okay, so you have K, NH4, so first thing, we always know that oxygen is -2. Oxygen is always -2. Right? So that becomes a -2, and that becomes a -2. So if it's -2 times 4, that's -8. -2 times 1, that's -2. So that makes the hydrogen plus 1. That makes the, so let's leave the AS for a second. The K is also a plus 1. That's always a plus 1. So anything in the first row is always a plus 1. And oxygen is always a -2. So these are standard. Everything else can change. So H is also usually plus 1 because it's in the first row. So that makes the N -4. Okay? So now we're left with the AS, which is what they're asking for. So it's not gonna be plus 8 because that's not even a legitimate oxidation number. So what you're gonna do is you're gonna add all these and you're gonna try to get it to be neutral. So plus 1 minus 4 plus 1 plus X, which is the AS, minus 8 so that's, sorry, minus 2 plus 1 minus 2. So, and all that is equal to 0. So X becomes equal to positive 5. And that's when D becomes the answer. Okay? So AS is not going to be plus 8 because there's no such thing. So it becomes plus 5 to make it neutral. So these are, so this is plus 1, this is minus 2. The -2 is from the O. No, you would use the -2. So use the regular, use these. What's that? You're looking at within the parentheses and then you can multiply by 2. So the 2 is for both. But when you're looking at oxidation numbers, look within the actual thing. Don't look outside the parentheses. So the number outside the parentheses, ignore it for the time being.
So like that's 6 as well, but I got that H.
No. No, no. The H is going to be a positive. The H is going to be a positive 1. Okay. The O is the negative 2. Okay. So oxidation numbers always, always, always on these for some reason. Okay. So 12. Balancing equations. So with balancing, it takes practice to do these. But the answer is that you get 1 MnO4, you get 1 SO3, you get 5 H pluses, you get 1 Mn plus, 1 SO4 2 minus, and 3 H2Os. So what is the coefficient for H2O? It becomes 3, which is A. Okay. And then 13. They also tend to ask this a lot, the one about transitions with a hydrogen atom. So this one is going to be this equation. So now you're looking at which one will have the longest wavelength. Okay. So with that one, the answer becomes C. So you're gonna, with this one, you're gonna have to try each number and see which one gives you the answer, because, or which one gives you the highest, the longest wavelength, because all of them have a difference of 1. They're all 3 to 2, 7 to 6, 5 to 6, but they're all here. 1 to 2 is increasing. 5 to 6 is increasing. 3 to 2 is decreasing. 7 to 6 is also decreasing. The longer the wavelength also means increasing. So you can eliminate B and D automatically. So now you're down to A or C. So you're going to try the numbers in and see which one works the most. And C becomes the one with the longest wavelength. Okay? Favorite question, 14, quantum numbers. So this one, you know, N, L, ML, and MS. So we already know that N is going to be any number. What is the rule for L? 0 to N minus 1, exactly. ML can be from negative L to L. And MS is either a plus half or a minus half, right? So which one doesn't work? C, right? Because L and N are the exact same number and they cannot be the same number. Good. 15. So which property of the oxygen atom is represented by the equation here? And again, this. So these were the periodic table trends. So remember, we had 2 equations. We had one for electron affinity, and we had one for ionization energy. So what is ionization energy? Losing or gaining electrons? Losing, exactly. So you want to remember the trends. So the trends going this way, and they're the same as going up. So for that one, if you're losing an electron, is this going to be first ionization or electron affinity? So it's going to be electron affinity, okay? Because it's gaining an electron here. It's the element plus an electron and becomes negative. So it's electron affinity. So energy required to gain an electron is electron affinity, okay? Perfect. So the next one, again, another periodic table trends. So focus on periodic table trends. That's also something that they like a lot. They have 2 questions on it that says something. So if you have 2 out of 40, that's a big percentage on one topic. So periodic table trends, something to focus on. Largest radius. So what is the trend for radius? Increase or decrease as you go this way? decrease, right? So the one with the largest radius has to be on this side. So which one of these has the largest radius? Also, these are all ions. So you want to remember that what the trend is in terms of comparing an ion to its neutral and comparing an ion to another ion. So comparing an ion to an ion is going to be the same trend as a regular atom. For comparing ions, they change. So we have cation is going to be smaller than its neutral, and an anion is going to be larger than its neutral, okay? For that one, the answer becomes C. Okay. Any questions so far? Good? Okay. 17. Which group best illustrates the transition from non-metallic to metallic behavior? So another periodic table. So we have 15, 16, and 17. And 18. So you have 4 questions about periodic table trends. I think that says something. So 17, which group best illustrates the transition from non-metallic to metallic behavior? So this side is what, metals or non-metals? Metals, right? And these are non-metals. So if it helps you remember oxygen, we breathe oxygen. We can't breathe a metal. So oxygen is the non-metals, and everything here is non-metals. These are transition metals, and these are also metals. So the trend goes this way with decreasing metallic behavior. So the transition from non-metallic to metallic with behavior, it's going to be B. So you also have to realize that it says with increasing atomic number. Okay. And atomic number is the 1, 3, 4. These are the atomic numbers. Okay. The number with the decimal is the atomic mass. Okay. And these are in grams. And then 18, which atom is likely to violate the octet rule? So remember this octet rule idea? So all the ones highlighted in red violate the octet rule by increasing, by going over 8. Then you have Be, H, as well as boron and aluminum. These can go under the octet, so this can only form 1 bond, 2 bond, and 3 bonds. Okay? So also knowing this can help. So which one can violate the octet rule in its compound? Or which one is least likely? So we know H can, fluorine also can. No, fluorine can't. Sorry. Chlorine can, and boron can. So it's going to be C. It's going to be fluorine. Fluorine is the only one that cannot exceed the octet. It's not even in the highlighted region. Okay? And then Lewis dot structures. So we have this, HCOOH. How many bonding pairs and how many lone pairs? So bonding are the ones with the lines, lone pairs are the dots. So if we draw out HCOOH, it becomes like this. HCOOH. Okay, so you have double bond, this is a C, and O. So you have 1, 2, 3, 4, 5 bonds, because this is a double bond. So 5 bonds. And you have 1, 2, sorry, this is not. You have 1, 2, 3, 4. 4 lones, but lone pairs are 2. So this is 1 lone pair, 2nd lone pair. So 2 lone pairs. So that makes Oh yeah, so it becomes 4. Oh, sorry, I forgot these. So becomes 4, sorry. So it's D. Let me redraw it neatly. So it's so 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Okay? And then largest lattice energy. So lattice energy, we figured it out using this equation. So these are the product of the charges, and this is the distance between the radius. So as the product of the charges increases, the lattice energy increases, and as the distance decreases, lattice energy increases. So these are inversely, these are directly. So the largest lattice energy means that they have to have small distance and large charges. So to figure out the charges, you're going to use a periodic table. Okay, so Li is going to be +1, and F is -1, so it's the product of 1. Be is 2, oxygen is -2, so that's 4. K and Br are plus and minus 1. Ca and S are plus and minus 2, so you can eliminate these. So now you're down to Be and O and Ca and S. Now you're going to see which one has the largest distance, and from there you determine that BeO is the correct answer. Okay? So because they have the smaller distance. Yeah. So since it's counting, so the question is how many bonding pairs. So since it's just saying bonding pairs, you're going to count everything as, so even double bonds are considered 2. But if it says how many, so that's different from when you're looking at their geometry. When you're looking at geometry, a double bond is still 1. Okay? Yeah.
Question. Wouldn't it be like lattice energy is like as increasing size it decreases? So could you just look at like molar mass too? Because I did that and I got the same answer.
Okay, so yeah, if it works, that'll be.
I don't know. I just figured that would probably be easier.
Okay, so molar mass, yeah, so definitely, yeah. Okay, 21. So this is looking at the bond energies. So, given the bond energies below, what is the bond energy of the O single bond? So, you have H2O2, so it's like this. Okay, now H2O2 becomes H2O and becomes O2. O2 is an O to O double bond. H2O is like this. So they give you the H2O and they give you the O to double bond O, but they don't give you the O to O single bond. So that's what you're trying to find. You have the overall energy that's released, which is 103 kilojoules. So what you're going to do is you're going to see if it breaks or if it forms. So anytime you break a bond, so this is going to break. This is the side that breaks. This is bless you. This is the side that forms. Anything that breaks, is going to be endothermic, so it's going to be positive. Anything that forms is going to be exothermic, so it's going to be negative. So here you have an H2O bond, so that's 1. You have an O to O bond, and then you have another H2O bond. Okay, so you're going to have 2 H2O bonds breaking. So it's going to be positive. This is also going to be a positive value because it's breaking, but you don't know what it is. So that's what you're trying to find. And then on this side, you have an H2O and another H2O, so that's something that you also have. And here it's going to be, you're going to change this number to negative because they're forming. And also you have the O to O double bond, and you're going to change it to negative because they're also forming. And then since you have the total, you're just trying to solve for something which is unknown. And in this case, this one becomes C. And it has to be a positive value because it's on the breaking side. Okay? So let's try it. So you have an H2O. You have two H2Os breaking. So that's 2 times 463. And then you're subtracting plus X minus 2 times negative 463 plus, so plus 2 minus 463 plus negative 498. So that's this, equals 103. So I don't have a calculator on me, but when you add this, and then subtract this, and then subtract this, and then you have all this plus X equals 103, you subtract all that from 103, because this is going to give you a large negative number, and then you're adding it to this. So it's going to be a negative number that you're going to add to 103. Well, you're adding X. So this and this automatically cancel anyway, right? So it's X minus 498 equals 103. All right. Yeah, give me one sec. Okay. Okay. I worked it out earlier and it came out to be 146, but I can't remember how. Okay. So X equals 5. Okay, let me get back to that one. I'll get back to that one. But did you get a different answer? Yeah, but I mean, when you tried it out, did you get a different answer than C? Anyone? A? Okay. Let me go back to that one. All right. Okay. Okay, I'll get back to that one. So 22 pi bonds. So pi bonds are in what? They're in double bonds, right? So a double bond has 1 sigma and 1 pi. A triple bond has 2 sigma and 1 pi. So C2H2 is going to be I thought I had 2 sigma 1 pi. Two pi 1 sigma? Okay. Sorry. Anyway, so CO2 has 2 double bonds. CH2 has a triple bond, N2 double, O2 double. So which one's going to have a different number of pi bonds? So you're going to have to calculate. So here you have 2 pi bonds. Here you have 2 pi bonds. Here you have that has a triple. Okay, so it has so it still has 2 pi, and here it has 1 pi. So which one has the different one? D. Because it only has 1 pi. Okay? Okay. 23. The geometries. So the Vesper theory and the geometries. So for that one, you probably have to draw out Lewis structures, or if you already know from looking at the chart way too much, you will remember. But for that one, the answer becomes A. So PCl3 is going to look like this. Okay. So for these, probably molecular. Yeah. So this is the only one that's correctly matched because trigonal pyramidal has 3, right? Right? So it's molecular. So this is the only one that's correctly matched. So look at the instructions also because where did you get tetrahedral? So you think it's tetrahedral in terms of molecular?
In terms of electronic.
Yeah, but here we're looking at molecular.
Oh, I know. Okay, I just wasn't sure if you put it as trigonal 5. Wouldn't that be
Give me a sec.
You guys called for help with the projector? No, it's okay. Thank you.
Okay, let me pull out the chart for a second.
Well, I know it's different. That's what I'm saying. I'm just saying for the way that we do it right now, wouldn't that be trigonal
Mm-hmm. Okay, so I think I misdrew this then. Because then it would be trigonal pyramidal.
Yeah.
Okay. Okay, so I drew these on accident. Sorry. Thank you again. Okay. So structural isomers. So you need to know the definition of isomers. So structural is what? And this is ABC. So it's same molecular formula, just different shape. That's structure. So think of structure, shape. They have different shape, but same formula. Okay. 25. So benzene reacts with oxygen to form CO2 and H2O. So anytime you see something reacting with oxygen, that's what? A combustion, right? How much O2 is required for the complete combustion of this? So how would you do that one? You have to write down the balanced equation to solve it. So you have C6H6 plus O2, and you have CO2 plus H2O. So let's balance it. So you have 6 carbons here. You have only 1 here, so you'd multiply this by 6. Okay, you have 6 H's here. And 2 H's here, so this would be 3. So 3 times 1 is 3, plus 12 is 15, divided by 2. So you get 9. So this becomes 6, sorry. So overall you get 9. So you get 9 O2s. So by balancing the equation, you can figure this out. Because they don't give you any grams or anything, so you can't really solve it any other way. So balancing the equation. And then the one after, so the formula of terbium phosphate is this. So what would be the formula for terbium sulfate? So if phosphate ends in PO4, then sulfate has to end in SO4. Okay? And then you want to know, okay, is it SO4 2 minus? So what is it? So TB is 3 plus, SO4 is 2 minus. Okay, so if you take these and switch them, it becomes TB2 and SO4 3. You can use your periodic table for that one. So, but definitely since, let's see, where's TB? TB is a transition metal, I believe. So transition metals, you do need to memorize what their oxidation is. But everything else, I mean, SO4 2 minus, it's a polyatomic ion. You need to memorize these. So C is the answer. And then, yeah. The what? Yeah. Okay, give me a second. Okay. Okay, so 6, 2. So if you try to put, okay, if you try to put 3, so you get 3 O's plus 12 O's, that's 15 O's, divided by 2. Yeah. Okay, for some, yeah, I'm going by the answers they had in the answer key. So they had C, but I'm gonna go with, yeah, it makes sense to be B. So I'm assuming some of their answers are incorrect. So go with B for that one. Because that's what I was thinking first. So go with B on that one. Yeah. That's what I got also, but then I went back and checked the answer key and they had C, so I changed it, I guess. So, but anyway. Okay, 27. A 25 milliliter sample of this molarity of silver nitrate is reacted with a 3.58 gram sample of calcium chloride. Which of the following statements is true? So if you look at all the answer choices, they're all talking about limiting reactant and precipitation. So they all have the term precipitation, but it's, okay, which one precipitates? So again, you need to remember, okay, solubility rules. So for that one, and again, starting number 25, this is another practice test. So you can see how like the concepts are going to repeat. So again, solubility rules, limiting reactant. These are another, it's repeating one more time. For 27, the answer becomes B, or in this case, C, I guess. So it's silver nitrate is the limiting reactant, and silver chloride is what precipitates. So silver chloride, because you have silver nitrate plus calcium chloride. So you have, this is a double replacement. Okay, so silver chloride is going to be a precipitate because silver this does not dissociate. It's not soluble. So it's what precipitates. And that makes silver nitrate the limiting reactant. So this is the limiting reactant if you work it out. Okay? Say it again. Okay, so if you work, so you have 25 milliliters of silver nitrate and 3.58 grams of calcium chloride. So the 25 milliliters is going to be, so if in terms of how much you have less of the sodium of the silver nitrate than the calcium chloride. So that makes it the limiting reactant. But in general, you can already see which one's going to be. So first thing is which one's going to precipitate, because this is something that you should memorize. So you should already know that the silver chloride is what's going to precipitate. So you eliminate these two. Now it's about looking at which is going to be the limiting reactant. And in this case, the silver is going to be the limiting reactant. So you're going to have to balance the equation and see how much of each you have and how much you can make. So in this case, the silver nitrate is what becomes the limiting reactant.
How do you know like
How do you what?
How do you know like in the relatively quick that the silver chloride precipitates?
So the silver chloride is going to, so in the solubility rules, most things that have Ag or silver tend to be non-soluble. So if it's non-soluble, it precipitates. If it's soluble, then it dissociates completely and you probably have no precipitate. Like the question that we had earlier where you got a clear liquid. I don't remember which one that was, but you had a clear liquid. So the idea of getting a clear liquid is that complete dissociation, nothing precipitates. Okay? So these are solubility rules. So look over solubility rules. So the one after is a 3-liter sample of helium gas is stored in a rigid sealed container, 25 degrees Celsius, 1 atmospheric pressure. The temperature is increased. What is the new pressure? So P1, V1 over T1 over T2. Okay. And you're looking for the new pressure. Okay. So that comes out to be C when you work it out. So again, remember to convert this to Kelvin. And remember to convert this to Kelvin. okay? And since you only get one volume, assume that the volume stays the same. Okay, so constant volume. So in a way, it can just be P over T. Okay? Good? All right, 29, bless you. So again, you're gonna count in that one. So you get 1A, okay? For the B's, you have 1, 2, 3, 4, 5, 6, 7, 8. 8 B's, sorry. 1A, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 C's. So it becomes D. So it's about counting. Yeah. Okay. 30 is the one I was telling you about. So it's about looking at, so this is the Q equals MCAT. But here it's not as simple as, okay, they give you something and they want you to find Q. It's about finding the final temperature. So the temperature after system comes to equilibrium because you have something added to another thing. Okay? So you have, this is T1 and this is another T1. This is T1 for the gold, this is T1 for the water. So you're gonna set Q1 to Q2. And what you're looking for is TF. Now you know that TF is gonna be the same on both sides. So delta T becomes TF minus TI. Now you have TI for gold and you have TI for water. But TF is gonna be the same for both, on both sides. So you're only solving for one variable. But that variable is on both sides. Does that make sense? Yeah? Okay. So for number 30, the answer becomes A. Or somehow the letters are not really that good, but it's 22.7. Okay. So anytime you see a box, it's an arrow. I apologize. So enthalpy changes, again, this one is going to be Hess's law. So Hess's law is repeated again. So 2 times A, and then B, it's gonna somehow cancel here. Oops. And then -2. And then D is okay. And then E and F is okay. So again, you're going to work out Hess's law again to get this equation at the end. And you're going to multiply these variables by the coefficient. And if it's a negative, just remember to change the sign. So for 31, the answer becomes B, which is -30. Okay? So of course. Uh-huh. So let me work it out. So you're gonna have Q1. So the mass is gonna be Q1 is gonna be Q gold and this is Q water. So the mass of the gold, which is given, the specific heat of the gold, which is that, or heat capacity, excuse me, and delta T. So it's TF minus TI. TI of the gold is 83 Celsius. So it's going to be TF minus 83, okay, is equal to 100 grams of H2O at 22 degrees Celsius, and the specific heat of water is 4.12, I believe. So I think they expect you to memorize that one. I think it is 4.128. So 4.128, and then 22, so TF minus 22. Now you don't know if TF is going to be greater than or smaller than 22 or 83. It's going to be somewhere in the middle, but you don't know. So it's definitely going to be greater than 22, definitely going to be smaller than 83. So in this case, you're just going to do this. So you're going to multiply these, then multiply by TF, multiply by 83. Same thing here. So you get something, a number, TF minus a number equals another number, TF minus a number. The numbers are you're gonna bring the numbers on one side and the TFs on one side, and then solve for TF. So TF is gonna be 22.7. Okay? So this is how they're not gonna give you straight up Q equals MCAT. They're gonna expect you to find some unknown variable. And usually final temperature, because it's unknown is on both sides. Okay? So, and then 32, again, oxidation number, so that also repeated. It's the oxidation number of C. So you always know the O is minus 2. Okay? So the H is going to be plus 1. So that's going to be times 2, so it's going to be minus 2 is 0, so C becomes 0. Okay? So the oxidation number can be 0. Nothing wrong with that. 32, again, which is technically 33. So that one is, what is the value of the quantum number of L for sp orbital? So remember SPDF? So that's 0, 1, 2, 3. So the quantum number L for P is going to be 1. Okay? And then 33. Which element has chemical properties most similar to those of P? So anything that's usually in the same group has the same properties. So which one is in the same group as P? N, right? N's in the same group as P and AS. Usually anything that goes after it is what becomes the right one. So it's going to be AS. So most properties similar to those of P. So yeah. So number 34? Which one? 35?
32.
Second 32, okay.
So basically we could look for just, let's say it's 5s, the answer would be 0.
Mm-hmm.
Okay.
Yeah, because the L, the quantum number L, is represented by the letter. So SPD or F is L. Okay. Mm-hmm. Okay, 34. Which halogen atom has the greatest electron affinity? So again, periodic table trends. So trends repeat, Hess's law repeats, oxidation number repeats. So you can see the trend of what to focus on when you're studying, right? You can see the questions style repeating. So halogen atom that has the greatest electron affinity becomes B, Cl. So halogens are group 7. So these are the halogens. Okay. And then you're looking at the trend. And then after that, again, the electron transition. So that same one repeated before, that same equation. So that same equation repeated. Okay, emission of visible light. Okay. So with emission of visible light, is it going to be higher or lower? It's going to be higher, right? So higher wavelength. So you're going to look at the emission spectrum and you're going to see, okay, where's visible light? and it's towards higher frequency and, lower frequency, higher wavelength. So for that one, it becomes A. Excuse me? Sure. So 1 over lambda. So you're solving for lambda, right? R is a constant. And it's 1 over, so this is going to be Ni, and this is going to be Nf. So Nf squared is going to be 4, Ni squared is 1 over 25. So you're going to multiply that by R, and you're going to put that number over 1. So 1 over equals lambda. Now you should know that it's going to decrease. So this is going to increase, this is going to decrease, this is going to increase. So if they increase, you can already eliminate them. Okay. So now it's between, okay, trying them out. So look at the answer for this one and then do 1 over lambda again. But this time, do 1 over 1 minus 1 over 9. And see which one has the highest wavelength. And it becomes this one. Sorry, not that one. This. So this one has the highest. Yeah, R is a constant.
What's R equal to?
I don't remember off the top of my head, but I think it was like, yeah, times 10 to the 9th, 10 to the what, 7th? Something like that. I don't remember exactly, but it's a constant. You don't really, you can tell by the math of it what's going to be. Like, you don't have to really multiply and all that. So you can tell that 1 over 4 minus 1 over 25 is going to be a bigger number.
So how can you tell that for the answer that it's going down, it's not going down?
So they're inversely proportional. So the lambda is inversely proportional with this. They're inversely proportional. So if one increases, the other decreases. Okay? And also you should know where visible light is in terms of the spectrum. Is it on the lower end or the higher? Okay? So this also repeated, so focus on that one. And geometry, again. Geometry of ClO3 minus, so Cl. And for that one, it becomes trigonal pyramidal, sorry. Okay. So what can be another question for that one? It could be a resonance structure, right? So things like that. Bond order of NO. So bond order is, the equation for bond order is what? Bonding minus anti-bonding divided by 2, right? So N on the periodic table has 7 total, and O has 8. So 8 plus 7 is 15. And remember, you're supposed to put it on the chart that looks like, hold on. The one with the bonding and the anti-bonding. So this chart. So when you put it on there, you're gonna get D as your answer, 2.5. So the bond order becomes 2.5. It's not two charts, it's that you switch something in it. So here, you're gonna switch the sigma antibond. After it should come the sigma 2p, excuse me. The sigma 2p only comes directly after the sigma antibond if it's more than 15 electrons. So this one, it's 15 electrons or more. So, sorry, if it's 15 electrons or more. So this one's 15 electrons. So you would switch them. So it would actually look like that. So this one's 15, so it would look like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you would switch them. So 13, 14, 15. Okay? So in the bonding is without the asterisk. So you have 1, 2, 3, 4, 5, 6, 7, 8. That's 8. Minus 7. Sorry, wait, hold on. Three, 4, 5, 6, 7, 8. Yes. And then 1, yeah. Divide by 2. I'll make it half. Okay. Okay, so then you wouldn't flip it then. So it has to be more than 15 in that case. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minus 1, 2, 3, 4, 5. So it's going to be 5 over 2, which is 2.5. How did I what?
No, like what was the rule?
So it has to be more than 15, not 15 or more. So it has to be more than 15. So more than 15 is when you switch it. Otherwise, the sigma comes, the pi 2p comes before the sigma 2p. Okay. All right. And the Lewis dot structure of ozone, which is O3, what is the formal charge on the central atom? So when you're looking at something that asks for formal charge, they're usually asking for the one with the best formal charge. So 3 oxygens, so there's going to be a double bond in there. Okay. So formal charge of the central atom. So formal charge is what? It's the valence electron minus the number of dots and lines. So the valence of oxygen is 6, and then you have 1, 2, 3, 4, 5. So 6 minus 5 is plus 1. So it's D. You see where that came from? So you have to draw the Lewis structure and then see what the formal charge is. And you have to draw the Lewis structure with the best formal charge. Okay? And then 38, hydrogenation of an alkene converts it to what? So this is the chapter that was on organic chemistry. So hydrogenation is adding a hydrogen to an alkene. So alkene is the one with what? Sorry. Excuse me? For that one? Well, you wouldn't, it's just knowing conceptually. So alkene has what? Has the double bonds, or one double bond, right? So when you add a hydrogen, you're making it more concentrated. So you don't need that double bond anymore, so you convert it to an alkane. Does it make sense? So when you have a double bond, that means that you have less hydrogens. But when you hydrogenate it, that means you're adding a hydrogen. So when you're adding a hydrogen, you're making it less concentrated. You're making it more concentrated with hydrogens. So you don't need the double bond. In that case, it becomes an alkane with only single bonds. Okay?
Would hydrogenation of an alkene or alkyne turn to an alkene?
So it makes it more concentrated with hydrogens. Okay, 39. What is the relationship between these two compounds? So you know it's an isomer of some sort. So when you look at them, you realize that they have the same structure, they look the same, but they have different formulas. And in this case, they become structural isomers. Okay, and then the one after. So starting here, we start the last practice exam. So the 2016, this is the 2016 one. So starting number 40 is the 2016 one. So from 40 to almost 58, that's a lot. That's a lot on just things that you learned in Chem 1. So since this is the most recent, you can see how it's going to be. So that's a lot of amount. That's a nice amount. So 20-gram sample of mercury 2 oxide is heated strongly, causing it to decompose to metallic mercury and O2 gas. What volume of O2 gas is produced? Measured at STP. Okay. So for that one, you're solving for a volume. And you're given 20 grams of this. If you're given 20 grams, you're going to have to convert it to what? To moles, right? Because you're using PV equals nRT for that one. So for 40, you're using PV equals nRT. So the 20 grams, you're going to convert that to moles using the molar mass that they give you. And you already have you have the word STP, and we said STP, which is standard temperature and pressure, means that the temperature is 273 Kelvin. And the pressure is 1 atmosphere, right? So you're given everything except for the volume, which you're gonna solve for, and you're gonna get A. Okay. All right, 41. When 30 milliliters of this molarity of AgNO3 is added to 30 milliliters of this molarity of NaCl, aqueous NaNO3 and solid AgCl are formed. So again, remember this, it came up before, the AgCl, and we said since it's a solid, it means it precipitates. So again, this idea of what precipitates, what's a solid, solubility rules and things like that. So how much of this is produced? So for that one, you're going to balance the equation. So you have AgNO3 plus NaCl, and you get NaNO3 plus AgCl. Okay? So you get 1, 1, 1, 1. And then you have 30 milliliters of this molarity. Anytime you have 30 milliliters, assume it's 30 grams. Okay? So anytime you get that, assume it's 30 grams. So you have 30 grams of AgNO3 Okay, and now you're trying to figure out how much AgCl is produced from that. So you're going to use stoichiometry, so 1 mole, and then you're going to figure out the molar mass, and so on. And then, so you know that 1 mole of AgNO3 is the same as 1 more AgCl. And the answer that you should get is A. This is the number of moles that are produced. Okay? 42. How much SrOH2, so how much of this, and this is the molar mass, is needed to prepare this amount of solution? And it gives you the molarity. So for this one, you know that molarity is moles per liters, right? So you have 0.1 m, and you know that is equal to a certain amount of moles per liters, because you have this number of liters. You have the molarity. So now you're going to solve for moles. Okay? So, using that, you're going to figure out that the answer is A. So again, it's another stoichiometry. You're solving for grams. So using multiplying these, you get 0.025 moles. Sorry. So you have 0.025 moles of this compound. And you know that 1 mole of this compound you have 206.76 grams of it, and you get the answer 6.64. But then you're going to divide that by 2 because you're trying to find OH. So you have OH2 here. So it's SrOH2. So because it's OH2, you're going to divide by 2. So 6.64 divided by 2 is 3.32. Okay, you see where that came from? Why did I divide by 2? So the compound is SrO2, OH2, excuse me. So since I'm only trying to find for just one OH, I'm going to divide by 2. Okay. So 43 is going to be containing carbon, hydrogen, oxygen. So you form this amount of carbon, this amount of hydrogen of H2O, this amount of carbon dioxide after complete combustion. So what is the empirical formula of the compound? So empirical formula. So you have CXHYOZ, and that gives you CO2 and H2O. Now you don't know how much of each, but you know the grams. So you're going to use that to figure out the amount of carbon. So you have let me use that. You have 23.98 grams of CO2. And in 1 mole CO2, you have how much? You have a certain amount of grams of CO2. Okay? And per 1 mole CO2, you have 1 mole C. So you're going to figure out how many moles of C you're going to have. And then you're going to do the same for H. And then you're going to figure it out for O based on the total mass.
Could you do this one?
Like all of it? Sure. Okay. So the molar mass of CO2 is, what is it? 44? Okay, so 44. Okay. So can someone calculate what it's going to be in terms of mole of C? Oh, thank you. All right, so we have CO2. Okay, so you have 16 times 2. You got it? Plus 2. Yeah, it's 44. Okay, so 23.98 divided by 44. So you have 0.545. Okay, and then you have 4.91 grams of H2O. You have 1 mole. H2O has 18. And you have in 1 mole H2O, you have 2 moles of H. So you have 4.91 times 2 divided by 18, so 0.546 mole of hydrogen. So now you don't know how much of oxygen. So you can figure this out by subtraction. So you know that, or by addition. So you know that in CO2, 23.98 CO2, and you know that in 1 mole CO2, you have 2 moles of O. So you're going to replace this by this. So it's going to be 23.98 times 2 divided by 44. So 1.09. And you're going to do the same thing here. The what? Oh, that's only 2, sorry. That's 2. Yeah, sorry about that. So 4.9, because you have oxygen in H2O and in CO2. So you want to try to find how many moles are in each. So 4.91 grams of H2O. And you know that in 1 mole H2O, you have 1 mole oxygen. So you're going to replace this by that. That's what you're doing. I'm just, instead of writing everything again, but I'm doing what you're saying. So 4.91 times, or divided by 18. So 0.273 mole of oxygen. So overall, you have 0.545 mole of C. You have 0.54, also 5 mole hydrogen. And you're going to add these together to figure out the moles of oxygen. So you have 1.36 mole oxygen. So what's the number in common? These are the same number, right? So you're going to divide by 0.545. So you have the number of moles of each. Now you want to find, okay, what's going to be the coefficients for the empirical formula? Because the empirical formula is CXHYOZ. Now we're trying to find these. So how can I find these? By dividing by a common factor. So this common factor is going to be 0.545 because it's the number in common for two of them. So you're also dividing this by 0.545. So that makes the carbon 1, that makes the hydrogen 1, and that makes the oxygen 2.5. Okay. So C1, H1, O 2.5. But since we cannot have 2.5, let's see. So for this one, the answer is B. So you can't have 2.5. So since you can't have 2.5 in a coefficient, you're going to divide. Okay. So let's do that. So you're going to divide by 2.5 for all. So it's going to be C.4, H.4, and then O, 1. So somehow the answer becomes C3H3O. Oh shoot. Sorry. So the answer becomes B. So either way, you know that C and H are going to be the same number. So these become the same, and this one's different. Does this make sense? Does it make sense? Like how you figure out the moles of carbon and then hydrogen, and then the last thing you find is oxygen. Okay? Okay. Good. All right. 44, which of the following is a non-electrolyte? So this is again the memorization part. And for that one, the answer is C. Okay. And then 45, 40 milliliters of this molarity aqueous NaOH is added to this milliliters. This molarity of aqueous, this, in a flask, tell you the temperature. Neglecting the effects of dilution, what is the Q? Okay. Oh, sorry, this one's not C. This one's D. Excuse me. So again, you need to memorize this. It's just memorizing, yeah. Okay. So let me figure out how much time I have. So for number 45, to figure out Q, you're going to write down the actual equation. So you have NaOH plus and it's going to be your replacement. So it's almost the same thing. And then you're going to do breaking or dissociation in this way, in this one. So it's Na plus 1 plus HCO3 minus plus Na plus OH minus. So it's dissociation. So let me rewrite that one. So for that one, you're going to get Na plus 2 of them, and then OH minus, and then HCO3 minus. So using that, you're going to figure out the Q by adding all of these or subtracting. So again, this side is plus, this side is minus. And for that one, the answer becomes C, number of joules. So a Q is in joules. Okay. And then 46, in a well-insulated vessel, you have 50 grams of ice at 0 degrees Celsius. So anytime you see something 0 degrees Celsius, convert it to kelvins. So kelvins and kelvins. So I'm just going to go over the answers for these because we don't have that much time left. But then if you have any questions on like how to get these, because they kind of repeat, so if you get the ones in the beginning, you can get these. But for this one, the answer is A. You just use Q equals MCAT. Again, this is similar to the other one because you're finding TF. So it's similar to the other one that we did. For 47, the answer is D. For that one, you're gonna just try to find the Cl to Cl bond by finding the sum and subtracting from the total, because this is the total. So you're just finding from the sum. For the one after, it's a conceptual. So this one, the answer is C. This is the definition of Hess's law. Okay. And then after that, this one is going to be B. So you're balancing the equation. So again, balancing equations is repeated. So it's just knowing that. This one is going to be A. So the Rutherford's experiment is the one with the gold light, is the one with the light and the scattering of it, and the gold foil. And this is the one that determines the positive charge of an atom, which is the proton. Okay. 51 is going to be B. So this is another periodic table trend. This is also another periodic table trend. And explaining the ionization, it's explaining pretty much the definition of ionization energy. So for that one, it's C. Okay. 53 is going to be again the NL, ML, MS. So it's going to be A again because N and L cannot be the same. 54 is nonpolar versus polar. So polar bonds, so you can have polar bonds, but since they cancel out, you get a nonpolar compound. So with CO2, you have C to O. So these are polar bonds, but because they cancel each other out, CO2 becomes nonpolar. Okay. Then 55, the answer is C. So with NO2 minus, you have 2 resonance structures. And you have this one. So these are the 2 resonance structures. And for both of them, The two resonance structures contribute equally to the structure, yes, and the formal charge on both is going to be 0. So because it's going to be 5 minus 5, and here it's 1, 2, 3, 4, 5. There's 1 dot on the nitrogen. And then 56, the answer is B, molecular geometry. Trigonal pyramidal. For some reason, they tend to like trigonal pyramidal because it's been the answer for all the ones that had geometry in them. So if you're in doubt, put trigonal pyramidal, I guess. And then 57, hybridization of carbon. So for that one, the answer is B, ethane. Yeah, sorry, that should be A. So this B, the second B. So for that one, you have so what's the definition of having an sp3? An sp3 is when you have something that has 4 bonds around it, right? So this has an sp3. So this has an sp3, this has an sp3, and they're both hybridized. Okay, so these are the hybridized 2 sp3s. Okay, and then the last one, the answer for this one is C. So how many sigma bonds in this one? This is supposed to be just a dot. So this one, it's gonna look like that. I'm gonna draw it real quick. Okay, so that's 1 sigma, 2, 3, 4. That has 1 sigma also, and 2 pi. 1 sigma. So overall you have 9 sigmas and 2 pi's. And does anyone have any questions? We have like 5 minutes for questions. Sorry. It is B. So it's one asking for molecular geometry.
Wait, it was.
Yeah. What did you get?
I got t-shirt.
Okay. Let's see. So let's see. I think I have. Okay, we can try to do it. So with IF3, I has 7, and then F has 7 also, times 3. So that's 21 plus 7, that's 28. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 25, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. You're welcome. Good luck, guys. So, okay, so you're gonna have to get, you're gonna have two double bonds with that one. Then 4, 6, 8, 10, 12, 14, 15, 16. Oh, I thought she was done. Third half is 28. Yeah. Okay, so you're definitely gonna have double bonds in here somewhere. That's the problem also, like, for some of them I got different answers. I think, are we done? Can I like turn this on? For some of them, like, I got different answers than what they wrote. But I just went with what they wrote. What's up?
What's the difference between first and second ionization?
So I'll get back to you on that one. So with first and second, so ionization energy is gaining an electron. So I'm gonna turn it back on then. So let's say X is a gas. Okay, so it becomes positive plus an electron. This is first ionization. Second ionization is that it's already plus. So it's X2 plus another electron. Does it make sense? So with second ionization, it's losing another electron. First ionization is losing one electron. One electron, and then second ionization, it's energy needed to lose a second. Now, energy needed to lose a second is going to be a lot larger than this. Okay? All right, so I have 3. I think it is T-shaped for that one, actually. That's what I got. Like when I drew it out. This is what I got when I drew it out. So I would say I think it is T-shaped also, like you were saying. But yeah. Did this help a little, or? Okay, so I think it is T-shaped also.
I know. I think I just like
I think it is T-shaped for that one, actually. I think it's T-shaped for that one. I think it's T-shaped.
I think the rest was like fine. Like I know now when I just like study more for sure.
Okay, so they repeat concepts. I think. So.
I see like periodic trends a lot.
Mm-hmm.
Go over that.
So.
Okay, thank you so much.
No problem. Good luck.